Hello, everyone. Thanks for having me. I would like to share my experience of my team in using dbt to create a collaborative data platform and how to set up a robust CI workflow so that the overall quality of your warehouse gets enhanced. A bit of contextual information to better understand why we did what we did. Mid-sized company, 100 employees, 50 engineers, more or less. We have very mature operational data, is what you might call average size. Each table is no more than a couple of terabytes, so it's not really huge size data. And my team was tasked with enabling the company to do analytics at scale, so creating some sort of collaborative data platform. We have to move within constraints. We want to be fast in executing. We want to have something easy to deploy and to maintain. Limited budget, so open source was key, and the team was just 2-person. Cloud solution, GCP, but this sort of translates to AWS, Azure, or any other kind of cloud vendor. So our architecture, it's kind of a cliche, almost. It's an ELT approach. We settled for Airflow as a scheduling tool, where a bunch of pipelines pulling data into the warehouse, either batch jobs or stream jobs. And we divided our warehouse in 3 layers, a landing area where you only have raw data, you don't touch it, you just store it. Then you create a staging layer where you do some cleaning, deduplication, quality check. And then a data mart where you typically model your data and expose it to your dashboard and to your notebooks. So we wanted to minimize the number of tools, and we want to have complete traceability of what we did, and that's why we chose dbt. We wanted dbt because then we could orchestrate all the transformation in the warehouse with one single tool, have complete lineage, and as a nice side product, if everything is transformed with the same tool, and that tool also has a catalog functionality, you get a catalog for free, which is quite nice. So what is dbt? Many of you probably will know the tool. You can imagine it as the T in an ELT architecture. It's a transformation tool. It does not come with a compute engine. It piggybacks on your warehouse. And the idea is that each model, each table, each view, it's a SQL file. You can freely mix SQL with templating language, such as Jinja. And what dbt does for you is compiles every file in plain SQL so it can be executed into your warehouse, resolve dependencies, and sequentially executes everything that you need to create in the right order. So the key idea here is that everything which is raw data lives somewhere, and then everything else could be rematerialized overnight if you needed to do so, just by using dbt. So dbt and Airflow work really well together, and the naive approach would be, okay, I have my files, I just need a bash operator, CLI instruction, dbt run, materialize everything. However, we were creating a collaborative data platform. We soon realized that this was not the optimal way, mostly because troubleshooting and backfilling and partial reruns would have been a problem if you have one task to do everything. So what we introduce is a dynamically generated DAG, where on the right-hand side, you see that each of those tiny green dots, it's a single task, it's a single model. This is really good not only for partial reruns, but mostly when you're a data platform team, you don't own every single model, you don't want to act upon every single failure. This is a good way to route alerts to data owners. So you have your data product, someone owns it, that's in the metadata, you can route alert of failures to the right team. You don't need to cover everything with your data platform team. So what the user actually sees is just the SQL files. We tried to hide as much complexity as we could in the CI workflow so it gets enforced once the user pushes something to the remote. We want to have everything controlled in Git, and since we're a software company, we try to treat SQL as code. So we try to mimic as much as possible the process that any software developer would follow with its software. Version control, so Git as entry point for everything. Linting of your SQL code, test everything possible, and PR review. PR review also is a key to share knowledge in what we want to have as a collaborative environment. So the user journey starts just by creating the local branch in Git. And what the user needs to worry is SQL, but also a bit of templating. So DBT is really good to hide some of the complexity, like you don't need to write explicitly or your merge statements, but it comes as a cost, and the cost is typically quite a bit of boilerplate in your YAML file. We soon realized users were not too keen in having all of that overhead, so we introduced a module officially released by DBT Labs called CodeGen, which in just a line of CLI can generate all of your boilerplate. So you as a user just need to populate the metadata, which you know, you don't need to worry about the structure of the YAML. And the nice part in this is that it can also propagate upstream documentation to your model. So we really want to keep everything well documented, and if you need to copy paste quite a lot of things which is already documented elsewhere, it feels like a waste of time. This is a really nice way to just automatically propagate everything which you are using and not modifying. So you write your file, you push it to the remote, and that's where the CI workflow kicks in. So we realized quite soon it was important to have the same standard of writing SQL. That's probably self-evident when you're writing your application in Python, but in SQL maybe it's not always the case. So we leverage a tool called SQL Fluff. It's a linting and auto-formatting tool for SQL. It's similar to what Flake8, Black, or those tools could do for Python. You as a company agree on a set of rules. This is the way we write SQL. We have this kind of indentation, this kind of spacing, leading, trailing commas, and whatnot. You define them centrally in your repository, and those rules will be enforced for every single file that makes it to production. So it's a really nice way to be able to quickly jump into someone else's code and kind of not have to struggle with the structure. Everything kind of looks the same. You have the same standard for writing things. And the nice part is that there is a fixed function, so you don't need to fix manually everything. You can, to some extent, auto-format whatever can be auto-formatted. And the result is that SQL is kind of recognizable by everyone. There is no, that you don't end up with a messy structure. So the code leans, it's well written. It gets somehow materialized, more to it later. And once your table gets materialized, that's where we start testing. And testing in DBT happens, we could say, on 3 different levels. The most basic part is you test the integrity of your data. It comes with a core module, uniqueness, non-null, primary keys, that sort of stuff. The second and most interesting layer of testing comes from maybe the business logic you want to validate. So we introduced something called DBT expectation. It's a module heavily inspired by Great Expectation, which you might have heard about. You can think of it as a unit test for data. So unit test, you assert that something fulfills some criteria. With DBT expectation, you expect column to upfill certain criteria. And the nice thing is that they're very verbose. They're almost written in plain English, you can see up there. So you don't need to know SQL. You know the business logic, you just say, I expect column A to have values between this range. I expect the maximum to be above a certain threshold. I expect this column to have this relation to this other. So you know the logic, you can literally write it there. You don't need to be a SQL ninja to do that. And the final level of testing that we have is more on a meta level. So we could test the test itself. Can you cover enough of your SQL with test? And the metadata. And testing metadata will become key because DBT offers a catalog function. So you keep your YAML file where you define your models together with SQL, and you can easily compile them in some static HTML content that you then maybe host on your internal web page. And if you test before merging your PR that there is complete metadata coverage, then you get a complete data catalog for free. So what we enforce as final step in our CI workflow is check that each column has a description, an empty description. Tables have an empty description. And perhaps the most relevant is that every model needs a clear owner. So there is no table which is not attached to a team or a person. And that means that you, maybe business user, can get into the data catalog, look for something. There is a nice data discovery functionality, find the dataset you think you might need, and then talk to the right person. So you have a very nice complete lineage and ownership of all your dataset. So this is pretty much the user journey. Most of it is sort of hidden behind the scenes. You create something that you think is good. If it's not, it bounces back from the CI workflow. So there is no way to push something to production which is not good enough. And somehow the complexity is also hidden, and the user is very much handheld to fulfill those criteria. So how does the materialization part instead works, and what sort of pain points we ended up having to face? Typical problems we face are how to keep a production and a dev environment separated, yet managing cost controls and execution time. So perhaps struggles that everyone with a warehouse is having, and also how to handle changes. But let's look first at how to set up a good environment. The first thing we realize is that we want physical separation production from dev, and we achieve this in GCP by just creating two different projects. And the key idea was users cannot write to production. You have your service accounts, you have Airflow, and everything that is scheduled will make it to production. You as a user cannot manually create anything. By doing so, we force users to test and create their own local branches in another environment, a test environment. And there we also realized there was a high chance of conflict, meaning that it's still the same environment, two different branches working on the same model. They might clash with each other. So we try to do what you might do when you develop your app. So you have your virtual environment, Docker container, another user, another virtual environment, Docker container. They have nothing to do with each other. We do the same here. So we prefix every branch with the name of the branch and create a plethora of data sets accordingly. This way you can see that there is a non-overlapping amount of data sets between different branches. And the risk is clearly that the amount of data sets might explode. So we had to introduce also life cycle rules, meaning everything in a dev environment, we only live 72 hours, I think we have, which is a good way to keep it clean, but is also even a better way to prevent creating long-term dependencies toward your dev environment. You don't want a dashboard consuming something which is not production. And since users know data will expire within 3 days, that's a good way to prevent so. Another struggle is how to reduce the amount of data scanned and how to make it fast. So it's not just a matter of cost, it's also you as a user implement a change. You want the CI workflow to give you something within minutes, not within hours. So suppose you're working on model C there in the middle, and it depends on some other models, and it will affect something more downstream. So the naive way would be you have your new clean slate environment, you materialize everything needed by your model, and everything affected by your model. That became quite fast, costly, and slow. So we introduced two approaches to mitigate this problem. The first, as an opt-in, is just reduce the volume of data needed. You're in a test environment, you don't need 3 years of data, you maybe need just a couple of weeks. Most of the tables we have are partitioned in a clever way, some temporal dimensions. So what we do is just partition pruning, get the last 2 weeks of data. That's as an opt-in because sometimes that's simply not achievable. Most interesting is perhaps instead how we reduce the amount of upstreams data needed. DBT introduced 6 months ago, something like that, a defer flag, meaning that when you are in a given environment, if your model depends on something which is not there, you can point it somewhere else. So you can say, for example, to your model, hey, don't use A and B. Don't recreate A and B, just use them from production environment. You only need to read them. They're not modified. So you read what you need, and what is modified instead you rematerialize. So what you end up with is the top box. Rather than scanning a huge amount of data, you only scan a limited amount and only really what gets modified by your PR, making it a much shorter feedback loop for your users. Final pain point is changes, and that became more and more relevant the more users we had, because sometimes you have your model, someone else start creating dependencies on it, you maybe don't even know it, and you have to introduce changes, breaking changes, or perhaps you don't even know you're introducing those changes, so how do you handle with those? We start by looking at how we managed to mitigate the problem of unwanted changes. So we have tests, and tests are great to capture errors. The main problem with tests is that you need to materialize your table. So that's kind of good in a CI setup, right? You are still in dev, materialize, test fails, you don't merge it. However, when you're in production, your tests maybe are run overnight, and tests are run after the table get materialized. So even if you have a failure, you get an alert in the morning, good, but data has still been materialized, and maybe a dashboard is consuming it, and your executive sees bad data there. So you're aware, but that made it to production, to the dashboard. So we want to prevent this from happening, and that's where contracts kick in. You can think of contracts as some sort of test which is run before materialization. So you enforce your contract, and before the table gets created, certain things are checked. They're usually kind of primitive checks, like primary keys, data type, uniqueness, non-null, but it prevents bad data to ever making it visible. So this is a really nice way to prevent unwanted change. And the next kind of changes you need to deal with is breaking changes that are necessary. So sometimes you have your model and you need to change it, but there is maybe a dashboard hook up to your model and you don't want to take the chance of breaking anything. So DBT introduced something called model versioning, and you can think of it as creating different physical copies of your models. They're all defined in the same YAML. You just define your differences, or V2 is just defined by the difference with respect to V1. You have a collection of model, and what DBT builds on top of it is a view pointing at what you deem to be the current model. So V3, for example, is the current model. So what get exposed is just a view on top of it where your dashboard will consume data from. And that gives you freedom to somehow keep still deprecated model, or maybe have some sort of pre-release, so that if you have a dashboard which is behind schedule, can't really update to the latest model, hey, you can consume deprecated stuff for a while, maybe give you a period of grace. And similarly, you can have pre-release. So I really want to use your new data. Well, not everyone is ready. Okay, go for the pre-release. So this is a really nice way to phase in and out your models. Clearly, you need to be a bit mindful. You could end up with 10 different versions of your model. So you're back to, hey, how do you manage cost and execution time? But it's otherwise a really smooth way to work with it. And yeah, so this is pretty much our experience. And what I can share with you is that it's been key having Git as the only entry point for everything. So nothing is created manually. So that makes it much more easy to have any sort of quality control, traceability, ownership, and whatnot. For user experience, it's been very beneficial for us trying to lower the threshold as much as possible. So we have a collaborative platform, you want people to use it. How do you do that? Reduce boilerplate, make it easy to link your code, so some sort of auto-formatting, and test metadata before merging, which might be maybe undesirable at the beginning for users, but in the long run, it really pays off having really good metadata. And as a maintainer experience, the key learnings are keep your environment separated and try to reduce the amount of data scanned from the beginning. Otherwise, things will explode eventually. So this is all I had. I'd be glad to talk with you guys if anyone is interested during the coffee break. Otherwise, thanks so much for your time.